find that this is also 0. When this is 0, this is also 0, and the output is also 0. I think this is enough to tell you, because all the combinations are being noted, okay, that this represents, okay, here when sorry, this is 0, okay, when here any one input is also first I get high output and then I get a low output. I hope that's clear. Okay, let us take the next one. The next question says that to get output 1 for the following circuit, okay, the correct option for input, because output is already given. The correct set of input is what? Okay, the question is that here I am having this gate, my outputs are passing from this one, the third output is here, and it is passed again to this kind of gate. This is my output y, this is a, this is b, and this is c. Okay, you have to tell that what is the correct answer for y. Okay, my output is a. Can I say here, I'm just doing this, okay? If you want to give a try to this question, just give a try. Okay, I hope you have given that try. So this is my OR gate, right? So I can say that since a and b are passing from here, this will be equal to a plus b. And since a plus b is passing through c, I can say that this is equal to, okay, and here from c is also passing. And this is my AND gate. So this will be a plus b multiplied with c. Therefore, I will be saying that this is equal to a plus b into c, which is equal to AC plus BC. AC plus BC. Now, okay, or I can simply write it like this also. I want the output to be 1. Can I say here that if my input A is 0, my input B is also 0, multiply by the output C, which is also 0, answer will be finally 0. So I cannot take this. Second case, if I take my input A is 0, my input B is 1, and my output C is 0. Again, this will be 1 into 0, that is 0. So this also can't be there. Next, if this is 0, this is 1, and this is 1. So yeah, I get the value as 1 into 1, which is equal to 1. Therefore, I will be saying that A is equal to 0, B is equal to 1, and C is equal to 1. Also, if A is equal to 1, B is equal to 1, and C is equal to 1. Also, if A is equal to 1, B is equal to 0, and C is equal to 1. You have to check for these two. Okay, whichever option matches with this, that will be the correct one. Okay, I hope that is clear. Just give a try and you will get the answer to this. Okay. Okay, let us take a next question. The next question is the output of the logic circuit in given figure. In given figure is what? Okay, so there is a circuit like this. Okay, there is a circuit something like this. Just a minute. Yeah. Okay, and this is over here. You have to tell that what is the output here. The input are A and B. What is the final output from here, which is equal to X. Okay, just give a try and then I will be explaining it to you. Okay, so what can I figure out from here? I can say that this is input A and B. So this is my and NOT. This is my NAND gate. So if A and B come here, what will be answer? It is A plus A into B whole not. A into B whole not. A into B whole not is then passing through a single input NAND gate. Single input NAND gate behaves like a NOT gate. So this is what equal to A plus B whole not into whole not. A plus B double not is simply equal to A plus B. Therefore, A into B. Therefore, the correct answer is A into B, and this behaves like an OR gate. No, this behaves like an AND gate. This behaves like an AND gate. I hope this is clear. Y is equal to A into B. I hope that is clear. Okay, sounds good. So let us take our next question. Okay, I hope every question which I am just checking is clear by your side. If you are having difficulty, guys, please let us know. Okay, well, do this question. The question says the output from a NAND gate is divided into two in parallel and fed to another NAND gate. Okay, the resulting gate is what? The resulting gate is what? Okay, so I am having like this. Okay, this is one. Okay, from here and another, it is being passed through another single input NAND gate. Okay, so the inputs are A and B. Okay, you have to tell that what is the output here. Okay, can I say that if this is A and B, my output from the NAND gate will be equal to A into B whole naught, and since this behave like a NOT gate, again I will be writing this is A plus B whole naught into whole naught, which is double naught, therefore it is simply A plus B. A into B, I'm sorry, A into B, therefore it behaves like an AND gate again. Okay, fine. Okay, you might be bored of doing these questions. Okay, let me give you a different kind of question. Just do that. The question says the figure, okay, the figure shows a logic gate. The figure shows a logic circuit of two inputs with two inputs of A and B. Okay, and the output C. Okay, the voltage wave forms across A, B and C are given. Okay, they are given to you. Okay, the logic gate is, okay, you have to tell that which logic gate does it represent. Remember I said that I am drawing the time graph because questions are being asked from there. Okay, so yeah, you can hear that this is such kinds of question. Okay, the graph is something like this. Okay, this is A, this is B and this is C. The graph for A is like this. Just a minute, the graph for this is something like this. Okay, the graph for B is something like this. I'm sorry, okay, the graph for B is something like this, and the graph for output is something like this. Okay, you have to just think that which gate could it represent. Okay, just think that which gate could it represent. Okay, this is time t1, this is time t2, and this is time t3, this is time t4, this is time t5, this is time t6. Okay, these are all mentioned. Now try to say that which of the following gate could it represent. Okay, the question is not too hard, just think of this. Okay, okay, I hope you have tried this. Okay, well, you can see that here when the output, when the, okay, for this let us draw the truth table as well. When input A is 0, input B is 0, the output is 1. The output is 1. You can see it clearly. Okay, sorry. When the input A is 1, the input B is 0, the output is 1. Okay, when input A is 1, input B is also 1, the output is 1, 1, 1, 0. When A is 0, B is 1, it is also 0. Okay, it is also 1. And when this is 0, okay, you find that this is also 0. When this is 0, this is also 0, and the output is also 0. I think this is enough to tell you, because all the combinations are being noted. Okay, that this represents, okay, here when sorry, this is 0. Okay, when here any one input is also high, the output is high, that means it is basically an OR gate. This is which kind of gate? This is an OR gate. You can see it clearly. Okay, you might be confused that here, since this is at top, okay, if I talk about T3, you can see that the wave for A is at this part, so you'll be thinking that this is 1. No, you have to not take it as 1, you have to think about this one. Why? Because it is coming down here. Okay, you have to mind about the slope here. Okay, I hope that's clear. Okay, this was a confusion that you may have here. Okay, and let's just continue this. Okay, is that clear now? Okay, guys. Let's take the next question. The question says that the symbolic representation of four logic gates are shown as, okay, the first one is like this. Okay, the second one is like this. Okay, the third one is like this. Okay, and the fourth one is like this. Okay, you have to tell, okay, you have to tell which is AND, which is NAND, and which is NOT. Okay, which is NAND, which is NOT, which is NOT. Okay, just look at the diagram and try to figure it out. Well, if I make a clear observation, I find that my figure 1 is NOR gate. Sorry, my figure 1 is OR gate. My figure 2 is AND gate. Okay, so AND is the second. Okay, third is your NOT gate. Okay, and the fourth one, make a guess. This is NAND gate. Okay, so the correct answer is 2, 4, 3. Okay, whichever option will match with it, that's the answer to this. Okay. Okay, the next question. Well, the question is the symbolic representation of four logic gates are shown as okay. You have to note that which represents which one. Okay, well, I think let us not do this. Okay, we have already done this. Let us take a different amount of question. Okay, right now we are taking a high amount of question, so just think about this and tell the answer. Okay, are you ready for this, guys? Okay, basically I'm asking you to solve the circuit. Okay, after every circuit drawn, please pause your screen and try this and try to solve it first yourself. Okay, then I will be telling you the answers. The first circuit is this. Okay, this is the first circuit. The inputs are A and B. The second circuit is this. Okay, the second circuit is this. The third circuit is this. Okay, this is the third circuit. The fourth circuit is this one.
Not effort. It's lack of personal attention. With one-to-one mentoring, every doubt is addressed, every concept is applied, and real improvement begins.